Assalamu alaikum wa rahmatullah and welcome to the Voice of the Cape's Matric Revision program for this year 2024 in collaboration with the Two Oceans Graduate Institute. My name is Ameer Adams and I will be presenting this particular segment. Of course, just doing the intro as well as the outro, inshallah ta'ala. And each and every session will be having a facilitator, and inshallah, as our beloved viewers know, on the Voice of the Cape's YouTube and Facebook page each and every year before the matriculants get underway with the trial examinations as well as the NSC exams. We have various facilitators who are experts in the field who are going to tutor you and give you guidance and advice, as well as, of course, in their discourses, emphasize the importance of preparing for your examination paper and also ensuring that in the various subjects they will deal with all of the matters that you will need as a means of assistance and as a means of you also training for your exams or preparing and studying and practicing for your upcoming examinations, inshallah. For today's session, our first session for this year, inshallah, we have our first facilitator who will be presenting today. He is the head of Supreme Scholar, and it is none other than Imam Natheer Hendricks, who will be conducting the first session for Mathematics Paper 1. Let me repeat, today's session is the first session for Mathematics Paper 1, inshallah. And without further ado, we hand over to Imam Natheer Hendricks, who will be conducting the presentation for everyone present, or rather for everyone who will be preparing for the mathematics exam, Paper 1, inshallah. Over to you, Imam Natheer.
Okay, Assalamu alaikum wa rahmatullahi wa barakatuh. Shukran for having me and shukran for putting together this program. We pray that Almighty puts barakah in this program and grants that everybody that watches this, inshallah, will benefit greatly from the work that's been taught, inshallah. Okay, so let's get into things, inshallah. Bismillah ar-Rahman ar-Rahim. Allahumma salli ala Sayyidina Muhammad. So, alhamdulillah, we are starting with this Matric Revision program. And for today's session, inshallah, as you can see the slides, we're going to be doing a little bit of an introduction for pure mathematics. And we're going to be touching a little bit on a very, very important section in mathematics, which is called algebra. Okay, so we're going to be looking at that, inshallah. What we're going to be looking at today is the following, as is on the slides. We will look at, we will just start out with a very important thing, something that I always tell my students when we begin, preparing for a big exam like the upcoming exam, which is, by the way, happening in 15 weeks. I don't know if people are aware, but the matric maths paper is taking place on the 1st of November this year, which is in about 15 weeks time. So there's about 15 weeks left for you to write your final mathematics paper for the year. So we're going to look a little bit at starting with the end goal in mind, just a little bit of strategies and things in order to prepare yourself adequately for the final exam. And then we're going to be having a little bit of an overview of topics of paper 1 and paper 2. And then we're going to jump straight into algebra, which is a section that is across the board. In almost every section in mathematics, there is some algebra that you will have to apply to solve the problems. And so we're going to look a little bit into algebra. We will look at what is algebra, just some very simple definitions that you've done, in previous grades that you might have forgotten. We're going to look at some basic algebraic equations. We're going to look at some quadratic equations, which falls under, which you need to apply algebraic principles in order to solve. And then we will look at typical exam questions connected to algebraic equations, inshallah. So that's what we're going to be covering today. And so let's get straight into it. Okay. So starting with the end goal in mind. What is the end goal, right? There's different ways to define the end goal, yeah? But if we're just very specific on what the end goal is in this context of preparing for your final exam, number one, to understand all the concepts needed to perform well in your final exam. That's a goal, right? And number two, which is more specific, is to get the most marks you can possibly get in the final exam. You've been studying mathematics now for all your whole schooling career, and when you get to the final exam, inshallah, that's going to be the test on all the different concepts that you've been learning over the years. You're going to need to be able to produce and show what you understand and show how you're able to solve the questions. And for all the correct answers that you give, obviously, you will get the marks. And for what you don't get correct, you obviously lose some marks. But the important point is that that 3 hours that you have for paper one, you have 150 marks, and you need to be able to get as much marks as possible in that short space of time. So the pressure is on. There is a little bit of pressure, but don't stress too much. If you've been studying and you've been putting the efforts in, at the end of the day, for us as Muslims, all we have to do is we have to put our best foot forward, put the best effort in, and then we give it a go, and the results will be good. So that's starting with the ending goal. Our classes, or this revision sessions, will be structured in such a way that we'll be looking at concepts, and then we will be pulling out exam questions just to give you an understanding of how the specific section that we're going to be explaining actually, how it gets tested in the final exam. So now let's look quickly at an overview of topics from paper one and paper two. In paper one, we have the following topics. We have algebra, and algebra is set there as a separate sort of section, but like I said earlier, it is a section of mathematics that basically is in almost every question that you attempt in both in paper one and paper two. There's some algebra or algebraic rules that you will use to solve that question, right? So algebra is an extremely important section because it's basically almost everywhere. In equations, so there's some equations, in paper one. There's some inequalities, which we will unpack. There's some number patterns that we will that comes in paper one. There's some functions and graphs. Functions and graphs is actually a massive section. There's some finance questions, growth and decay, and in that section is equations as well, which has algebra included. There's some calculus, which is a big topic, and then there's some probability and counting principles, right? And something important also that we need to understand is we need to understand what the different sections weigh in terms of the marks that you are able to get in the final exam for each section. Why is that important? The reason why that is important is so that you can strategize, you can make good strategies to make sure that you get most of the marks. As we mentioned in the previous slides, the goal is to get as much marks as possible in the different sections. So we're looking at the weightings, right? If you look closely, you will see that there's two sections that have lots of marks in the final exam. This is the typical breakdown of paper one. You have algebra, equations and inequalities, which count for about 25 marks, plus minus. Some, it can vary. We have number patterns, which counts for 25 marks. We have functions and graphs, which counts for 35 marks. Functions is a very, very big section. Which we will be covering in later sessions. Functions is your straight line graph and all of the properties that goes with that. Your quadratic, parabola graph, your hyperbola graph, your exponential graph, and so on. All of those things, very important, very big section. And then we have finance and growth, which is a little bit less from Mark's perspective. And then we have calculus. Your first principles, derivatives, and all of those questions. And then we have counting principles and probability. And that makes up the 150 marks that you will be looking at in your final exam. So this is important to take into account. And like I said, even though algebra is listed as one section here, it's not true that algebra only counts for 25 marks. There's algebra in every single section. There's algebra in equations and inequalities. There's algebra or some algebraic principles that you apply in number patterns. There's some algebraic principles in functions and all of these different sections. And then for paper two, we have statistics and regression. We can look at the mark allocations. Statistics and regression, which is about 20 marks. Analytical geometry, a big section, which is 40 marks. That's almost 30% of the one paper. right? Trigonometry, massive section, and then Euclidean geometry, which is also a very big section. So take this into account. Look at all of these things, and work out your time and where you focus your energy, and make sure that you can get as much marks as possible from different sections in the breakdown. All right. So now we will get into some algebra. Let's get our hands dirty. Let's get our hands. Let's get into the work a little bit. Okay. So, what is algebra? Very good question. What is algebra? I don't know if you remember the definitions, but there's different ways to look at it. This is not a formal definition. This is an informal definition. I try to simplify it and use simple words so that you can understand it clearly. Right? But what is algebra? It is a section of mathematics that uses letters and numbers to solve problems. That's what it is. Section of mathematics that uses letters and numbers to solve problems. You might be wondering why letters. The reason is because the letters simply represent any number. And when you are able to use a symbol, you could think of it as symbols, to represent any number, and you are able to manipulate and move those symbols around in such a way that mathematical principles hold, then you are able to generalize a problem. It doesn't matter what the numbers are. So it's very useful to be able to use symbols and move the symbols around whilst maintaining mathematical principles and logic, right? So you can extend a problem to different problems using different numbers. So that's one way. That's one sort of simple definition for algebra. Another way to look at it is it includes almost everything. Like I actually mentioned this earlier. It includes almost everything from solving basic equations to solving more abstract, complex problems. Okay, so it is a section that deals with the rules that you will use to move around numbers, symbols, and you use it everywhere, even in sections like trigonometry, for example. If you're busy with a trigonometric equation, then you are moving around the functions sine, cos, and tan, right? There you use algebraic principles, right? Algebraic rules in order to manipulate and move things around in such a way that they are sound and they hold to the logic of mathematics. Here we go. It teaches us rules of how to move symbols around to solve problems and find answers. That's what algebra is, right? It teaches us the rules of how to move symbols around and solve problems and find answers. So I hope that gives you some that's revision. I hope it gives you some clarity as to what algebra actually is, right? It's the section of mathematics that allows you, that shows you, that teaches you rules, that establishes and explains rules that you can use to move symbols around in equations and in different spaces to solve problems. Okay. All right. So we are going to be looking at some basic algebraic equations, very basic algebraic equations, just to refresh and to get the mind going. Something very simple. Question mark plus 5 is equal to 10. What are we asking here? When we look at this, something like this is an equation. This is an equation, right? This is a basic algebraic equation. You guys probably know the answer already when you look at this. But I just want to point out something very important. And I put the question mark there for a reason, because some people still get confused with what is x, why are we using x and y and all of these things. There's reasons, obviously. What this equation actually can be translated into English. You could think of mathematics as a language. That equation over there is asking you something in English. Right? What is it asking you in English? It's asking you, what plus 5 gives me 10? That's what it's asking you. I put question mark there, plus 5 equals 10. What it's actually asking you is, what number plus 5 equals 10? And the answer is quite simple. Right? The answer is quite simple. But we are interested not necessarily in the answer, but we are interested in rules that we can use for any problem like this to find an answer. Right? If it was a little bit more complicated numbers, then Then how would we do that? So this is a very simple one, right? So you will know, you will remember from maybe the previous grades that when I have something like this, what plus 5 is equal to 10, I could replace this question mark with an X or Y or A or B or a letter, some letter that represents something, right? Some kind of number. And then I could solve it and using the same principles that I'm going to show you right now for this one over here. So you guys know that there's this principle in algebra. If you are adding something on the one side and you want to figure out, and it's equal to something on the other side, and you want to figure out what is that thing equal to, there's this rule that you can, there's two ways to look at it. You can take the 5 over the equal sign. And when you take the 5 over the equal sign, the rule, the algebraic rule is that you change the sign. So it's positive on the left-hand side of the equation. And when you move it over, it becomes minus. So that's one way to look at it. And then you have the question mark alone. And then you can simply do normal basic math. 10 minus 5, and the answer is equal to 5. The answer is quite simple. The principle and the method is important. Right? That's a very important thing to understand in mathematics. The method is more important than the answer, because the method is what you use to find the answer, regardless of the numbers and everything that you can extend, a generalization that you can extend to different problems. So yeah, I used question mark. We could use A, B, C. We could use X, Y, Z. We could use letters. The usual letters that we use is X and Y, and there's reasons for that as well, because X actually means something. It stands for something on a axis, right? Okay. So let's put another one. Very simple. X minus 5 is equal to 7. What's the rule? The algebraic rule tells me that I can move the number over the equal sign, but I have to change the sign. So, take the 5 over, it becomes positive. And then X is obviously equal to 7 plus 5, and that's something that, you can work out. Very basic, very simple. This is just simple revision for you to remember the basic rule of moving things over the equal sign. Okay, very, very simple things. Okay, let's move into some more complicated stuff. So I'm going to jump over and assume that you remember the multiplication rules, you remember some other rules over there, and then we're going to move now straight into looking at some more complex problems, which is more relevant to matric, quadratic equation examples. Why am I jumping straight to quadratic equation examples? It's because it's guaranteed that you are going to get a quadratic equation in your final exam. Some form of quadratic equation you're going to get in your final exam. And so we can unpack what is a quadratic equation, and we're going to be solving some problems. But the point is, you are going to get a quadratic equation in your final exam, and you need to know how to solve them. At least 10 or 15 marks, more probably. Some in the first question in your final exam, there will be quadratic equations, very likely quadratic equations in the function section and in different places, right? And it will total to quite a bit of marks. So this section is very important, and we will use algebraic principles and laws in order to solve these kind of equations. So let's look at a problem. Let me just bring my whiteboard up so we can have a let me just I just want to bring my whiteboard up so we can do some presentation. All right. Okay. So we are going to be doing a problem. The problem is going to be, we're going to work through a problem quickly. The problem is x squared plus x minus 6. X squared plus x minus 6 is equal to 0. Okay. So we're looking at this quadratic equation, and we are looking at this quadratic equation, and we will try to solve this equation. Okay. Let me just remove this. All right. So how do we solve this quadratic equation? The first thing that we need to actually maybe ask ourselves is, what is a quadratic equation? A quadratic equation is usually in this form where there's three numbers, or three symbols, you want to call it. The first symbol normally has a squared. The second symbol is to the power of 1, and the last symbol is a number, usually, and it's equal to 0. And we want to solve this equation. In other words, what we want to do is we want to find out what number squared plus that same number minus 6 is equal to 0. So there's multiple ways we can look at and solve a problem like this. One of the ways we can solve a problem like this is to do what we call factorization. And I don't want to just jump straight into it. I want to actually explain to you guys what is factorization. Like, I'm assuming, let's just try to explain what factorization is. So what is factorization, and why does factorization work in a question like this in order to solve it? What is factorization? Right? Factorization is when we take a number and we break it up into two numbers, or three numbers, or four numbers that multiply together to give that number. So it doesn't have to be limited to a number. It can be any expression. When you break that expression up into two things, or two parts that multiply together to give the original number. I'll repeat that. Factorization is breaking up either a number or an expression into two parts, or three parts, or four parts that multiply together to give the original expression or number. Okay. The question is, why do we want to look at factorization when we want to solve this? The reason is because we have a 0 on the side. And we know that if we can factorize this expression on the left-hand side of the equation, if we can write it in it as a product of two things, then there's a principle that we can apply. And that principle is, this is what we want to actually end up with. We want to end up with two brackets multiplied by each other to get that equals to what's on the right-hand side. Why do we want to get it like that? Because there's a principle that says if two numbers, and it's algebraic principles, if two numbers, let's say A is some number multiplied by B, if two numbers are equal to 0, or two numbers multiplied by each other equal to 0, then there's only one of two possibilities. There's only one of two possibilities. Either the first number will be equal to 0, or the second number is equal to 0. And you can test that principle out. It's a principle. The principle states that if there's two numbers multiplied by each other that's equal to 0, then there's only one of two possibilities. Either A will be equal to 0, or B will be equal to 0. No other possibilities exist. Or B must be equal to 0. Right? So using that principle, if we can break up this expression, x squared minus x squared plus x minus 6, if we can break it up into two pieces that multiply together to give that, then we will be able to separate the two, make them equal to 0, and solve and get values to satisfy this equation. Okay, so that's the principle that we use, and that's the reason why we're using factorization, because as we said, factorization is simply breaking up. I'll write it out I'll type it out. Factorization is breaking up you could say a number or an expression. Let's say an expression. When I say an expression, I mean some form of an expression, breaking up an expression into multiple parts that multiply with each other, to give the original, to give the original expression. Sorry, writing is big. Let's make it a bit smaller. We could just do this. This arrow. I don't know where this arrow came from, but this arrow can go there. That's what factorization is. Okay. Okay. So that's what we're going to do now. We're going to break this thing up into two parts that multiply with each other to give me the original equation. Okay. So how do we do that? So the method is as follows. The method is as follows. We take this last number over here, right? 6. I'll write it over here. And we look for all of the different factors that multiply with each other to give me that number. So the first two factors is 1 and 6. 1 multiplied by 6 is 6. The next is 2 and 3. Right? 1 multiplied by 6 is 6, and 2 times 3 is equal to 6. Then what we do is we are looking for, listen carefully, here's the tricky part. We are looking for two numbers here multiplied by each other that will give me that number, which is 6. But at the same time, we must be able to add or subtract it to give me the coefficient. When I say coefficient, it's just the number in front of the x. It must add or subtract to give me that number over there. So if I multiply 1 by 6, it gives me 6. But is there a way that I can add or subtract 1 and 6 to give me 1? Nope, there is not. Right? So 1 and 6 will not be an option. And if I say 2 multiplied by 3, yes, it gives me 6, obviously. But is there a way that I can add 2 and 3 to give me 1? Yes, there is. Right? So 2 and 3 is going to be the numbers that I put here. 2 and 3. You can put it in any order. Doesn't really matter. And the first number will always be x. Provided that the coefficient, the number in front of x squared is 1, the front number here will always be x. Okay. So x times x is equal to x squared. Now we're saying that this bracket over here times this bracket over here is going to equal to that expression over there. Now we're missing some symbols here in between. How do we find out those symbols? Well, how do I add 3 and 2? Or what do I do? How do I combine 3 and 2 by using adding or subtraction in a way that it will give me 1? Well, it will have to be 3 minus 2. That's the only way. Right? So 2 must be negative and 3 must be positive. And that would be the two brackets that multiply with each other to give me that expression over there. And you can test it out if you remember FOIL, first out in last, right? So x multiplied by x gives me x squared. X multiplied by x gives me x squared. X multiplied by 3 gives me 3x. Negative 2 multiplied by x gives me negative 2x, and negative 2 multiplied by 3 gives me negative 6. And then I have the two terms in the middle. So it's x squared. Let me write it out for you. So just to make sure that you see it. And then x times 3 is plus 3x. Minus 2 times x is minus 2x. And then minus 2 times 3 is minus 6. And when we have like terms in the middle, when we add these two terms, 3x minus 2x gives me 1x. Okay. So I just wrote that out there just for you to see it, right? But that essentially is, so it proves to me then that expression there, actually, when I multiply it out, it equals to that equation over there. And then from there, what do? We apply this principle that we explained earlier. We say, okay, if there's two brackets or two expressions that are multiplied by each other to give 0, then there's only one of two possibilities. X minus 2 must equal to 0. Or x plus 3 equals 0. And now we have two simple equations, very similar to the equations that we had in the previous slide. And so now we can apply some algebraic principles to get values for x. If x minus 2 is equal to 0, the algebraic principle tells me I can take the 2 over, and x will be equal to 2. Or x, same thing over here, take the 3 over. When I take it over, change the sign, x is equal to negative 3. And that is the two solutions for the equation on top over there. To translate it into English, what are we saying? What we're saying is that if x is 2, then 2 squared plus 2 minus 6 will equal to 0. And at the same time, negative 3 also works. If I put negative 3 into this equation over here, negative 3 squared plus negative 3 minus 6. If you put that into a calculator, you will find, or if you just calculate it, you will find that it will satisfy this equation and will make it equal to 0. Therefore, those are the two solutions. We always expect two solutions. Why? The reason why we expect two solutions is because of the squared over there. That x squared is actually telling me that there are two possible solutions for x. Okay. So that is the an example of how to solve a quadratic equation, meaning find the values for x using algebraic principles. Okay. We're going to look at another problem. We will look at just another one, just to give you some more practice on this, and then we'll work through it together, and then we will conclude with some typical exam questions. Okay, so let me just erase and let's put another one on the board. So the next question that we're going to be looking at is, and we'll apply the same principles, right? There are other ways to solve questions like this, by the way, right? There's the quadratic formula, which we can explain. In fact, I think it's better if we're going to just explain the quadratic formula. That's another way of solving any quadratic equation. So let's just erase. Just erasing this over here. Okay. Okay. So let's go with a problem that we're going to use the quadratic equation to solve. Move to a different space just to get out. Okay. So the next question that we're going to look at is another simple one: x squared plus 8x plus 10. X squared plus 8x plus not plus 10, sorry, plus 12. Sorry. Plus 12. Okay, is equal to 0. Instead of using the method of factorizing, we're going to use another method, which is the method of using the quadratic formula. Now, this quadratic formula is a formula that's used to find the value of x in any quadratic equation, and this formula is actually given to you in the final exam. You will get an equation sheet, and on the equation sheet they will give you the quadratic formula. The quadratic formula is x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. And I'll unpack quickly what all of these are, right? Remember, the standard form for any quadratic equation is ax squared plus bx plus c is equal to 0. That's the standard form for any quadratic equation. So the a, b, and c that you see in this equation over here is simply these letters that you see. A is the coefficient or the number in front of x squared. B is the number in front of the x, and c is the constant term. This is some people prefer doing it this way. I must warn you though that if you use this way for the first question, the typical first question in the matric final paper, you might lose marks because they give you marks for factorizing as well. So you could use, I would highly recommend that you learn both methods. This equation is very, very easy to factorize actually. But I want to because we've gone through an example of factorizing, I want to show you quickly how to use the quadratic formula. So let's see. It's just a matter of putting the numbers in the proper place. So identify first what is your a. In this example over here, a is equal to 1, b is equal to 8, and c is equal to 12. And then it's just a matter of substituting correctly into the quadratic formula, and then you will get your answer. Many students who use this method many students make mistakes with substituting things incorrectly. What I advise is that if you have the Casio calculator, you use brackets, right, to put in all the numbers. So we can say, okay, x is equal to this plus and minus over here. It's simply telling me, remember, that for any quadratic equation, we have to have two possible solutions. So it's telling me that the one solution is minus b plus square root of b squared minus 4ac over 2a, and the other solution is minus b squared minus 4ac over 2a. That's it. So what is b here? In this case, b is 8, so it's going to be minus 8, right? And the first solution is going to be plus, minus 8 plus square root of b squared is going to be 8 squared minus 4 multiplied by a, which is 1, multiplied by 12. Right, over 2 multiplied by 1. And now it's a matter of doing some calculations. That's the first possible answer, or minus 8 minus 8 squared minus 4ac, which is 4 times 1 times 12. You can leave the 1 out if you want to, but I'm just putting it here for the sake of explaining this example, over 2 multiplied by 1, which is just 2. Right? And now you just do your maths, right? 8 squared is 64. 4 times 12 is 12, 24, 36, 48. So it's 64 minus 48. So you have your minus 8 on the outside, and you have plus the square root of 64 minus 48, right? Which is, what's that? 64 minus 48. You can write it down. 64 minus 48. You could just put this in the calculator, and you will get your answer. Over 2, and you can say 64 minus 48, that's 48 that's 2, so it's 50, 60, so it's 12 plus 12 plus 4, 16. So this becomes 16, right? So we could say that that's 16, and you guys should know that the square root of 16 is 4. So your first solution is going to be minus 8 plus 4 over 2. And your second solution is going to be minus 8 minus 4 over 2. When you use the quadratic equation, it's not normally such great answers. Most of the time, it's going to be the second question in the exam paper is usually a question that requires you to use the quadratic formula, and and using it, oftentimes you get decimal numbers. Okay, so now we've gone through two methods of solving a quadratic equation. And I think we're going to be looking at the last example now, an example of something more complicated, right? A little bit more of a complicated question, which we can look at if we just move my screen, let's move across. So now we're going to look at a little bit more of a complicated question, which is 2x squared minus 3x, 2x squared minus 3x minus 3 is equal to 0. Okay. How would we solve a question like this? Well, there is two methods that you could follow, right? I would recommend that you follow the method of using the quadratic formula, right? So let's remember the quadratic formula again. X is equal to minus b plus minus square root of b squared minus 4ac over 2a, right? Plug it into the formula and get your answers over 2. Okay. A general way to sort of tackle these questions, if you find there are different methods of solving, you cannot use you can use that method that I showed you of factorizing, but you have to be careful here and factorize properly. There's different methods of factorizing over here. I would recommend that you use the quadratic formula to solve a question like this. 4ac over 2a. Right? So then, yeah, in this case over here, our first x is going to be what? First x is going to be minus 3. Very important. Remember that you have to take the b value with its sign. In the previous question, we had a positive value, and so we didn't really need to carry the sign with us because positive is by default, right? But here in this case over here, it's a negative 3. So it's important that we carry that with us. And like I said earlier, we use brackets. Plus square root of b squared. Again, it's negative 3 squared. Do not leave your brackets out because you're going to get the wrong answer if you put 3 in with a negative and you don't put brackets in on a Casio calculator. You're going to get the wrong answer. It's going to give you negative 9, and negative 3 squared is not negative 9. Just to point that out, there's a difference between negative 3 squared. This is such a common mistake that you see so many people always. There's a difference between that and negative 3 squared, right? This over here says negative 3 multiplied by negative 3, which is positive 9. And this over here says negative 3 multiplied by 3, which is 9. This comes out positive, this comes out negative. So if you put this thing wrong in the brackets, right, it's going to give you an error. You're going to do all that work and it's going to give you an error, right? So you need to make sure you put that incorrectly. Minus 4. And then the a value over here is 2. And the c value over here is negative 3. Right? Very important. Negative 3. It's negative. Okay, so you have to take the negative word. Over 2 multiplied by 2. Again, if you do not carry these negatives properly, you're going to get errors here. You're going to get problems. Okay, so that's the first answer. And the second answer, just need to make some space over here, is obviously going to be that exact thing, but just, we can say or, but just or x is equal to negative 3 minus square root of that whole thing over there, which is negative 3 squared minus 4 multiplied by 2 multiplied by negative 3 over 2 times 2. Now you simplify. Let's do some algebra. Negative, so some algebra revision. Negative times negative is a positive, so that first number becomes 3. Plus, what do we have under the square root? Negative 3 squared is positive 9. Minus times minus is positive. 4 times 2 times 3. Get rid of the signs first. So negative times negative is positive. So you know that whatever that answer is going to be, it's going to come out as a positive number because I have a negative number here multiplied by a negative number. Then I say 4 times 3 times 2. 4 times 2 is 8 times 3 is 24. Right? Again, I can't emphasize this enough. So many students get stuck here because they make mistakes with the negative signs. Be careful for that. No? Over 4, and you lose marks unnecessarily because of the mistakes. So it's 3 plus square root of 9 plus 24 over 4, or 3 minus, and this is going to be the same, 9 plus 24 over 4. Okay. And then we go further. We need to simplify that. We're going to simplify that square root. 9 plus 24 is going to be 33. So it's 3 plus square root of 33 over 4, or 3 minus square root of 33 over 4. Okay, you could leave your answer like this, because if you know your square roots, you will know that square root of 33 is not a whole number. You could leave it like this, or you could simplify it a little bit more. You are allowed to be a decimal number. The square root of 33 is between what? The square root of. How do we quickly find square roots? It's just another last example before we end the lesson off. How do we quickly find square roots? A quick way to find square roots without using the calculator. Right? We're looking at square root of 33. Now, how do I know automatically that square root of 33 is not going to be a whole number? Well, because I know that 33 is not a perfect square. We know the square root of 36 is 6. We know that, right? Square root of 36 is 6. And we know the square root of 25 is 5, right? So it's a nice hack to understand this. So because 33 is between 25 and 36, the square root of 33 is going to be a number between 5 and 6. Right? Square root of any number between 25 and 36 is going to be 5 point something. So the square root of 26 is going to be 5 point something. The square root of 27 is going to be 5 point something. So I know automatically that the square root of 33 is going to be, this is guessing without looking at the calculator, 5.5 or 5.6, somewhere there. You can check it on the calculator. So because that's going to be a decimal number, this entire number is going to come out as a decimal number. Right? So that's why you could leave it like this, or you could put it in the calculator and get your final answer. Yeah, so that's that. And I think that's enough for today's lesson. In our next lessons, we will unpack a few more questions. By the way, this question that I just dealt with right now is a question from one of the papers. I think it's from the 2023 paper. And it is worth at least 4 or 5 marks. Right? So have a look at that. Go through past papers. I hope this session was helpful. And we will conclude the session here, and we will continue in the next session. Shukran very much. Assalamu alaikum wa rahmatullah.
MashaAllah, we say shukran, jazakallah khair, Baitra Makasi. Thank you very much to the head of Supreme Scholar. It is none other than Imam Natheer Hendricks, who so beautifully facilitated today's session. And that was, of course, pertaining to Maths Paper 1. Just as a reminder to all of our beloved viewers that this has to be sent out to all of the matriculants within our entire region, and of course within South Africa at large. And we encourage all of you are viewing, whether it be the parents of matriculants, or if you have family members who you know are in matric, please encourage them to tune in and to be part of these sessions that is being conducted by the Voice of the Cape annually. And this year, the Voice of the Cape is having its Matric Revision program in collaboration with Two Oceans Graduate Institute. As a reminder, please like and share this. And of course, indicate that this was paper 1 or pertaining to mathematics paper 1, inshallah ta'ala, as a means of our first session for Matric Revision for this year, inshallah. Once again, we'd like to say shukran to everyone who viewed this session. Don't forget to like and to send and forward this particular link to everyone else, specifically those who are doing pure maths. And inshallah, we hope that this will be of great benefit, as well as all the sessions to come will be of great benefit to all of our matriculants who are practicing and preparing and studying for their upcoming trial examinations, and of course ultimately preparing for the NSC examinations for the end of the year, inshallah. We wish all of our matriculants all of the very best, and we hope that inshallah everyone will take great benefit from our esteemed facilitators in the coming sessions, inshallah ta'ala. From our side, we'd like to say shukran and baitra makasi to everyone for tuning in and for viewing this session, and inshallah we hope to see you in the forthcoming sessions, inshallah. Assalamu alaikum wa rahmatullah.
Alaikum salam.